Hello, my name is Daniel Pyzak. I am very happy to be with you today to talk about one of the jewels of CATIA. Last time I talked about virtual to real shape morphing, but this time I would like to introduce to you a new app, a new product called Generative Shape Morphing in 3D Experience CATIA, but it's called Generative Shape Optimizer in V5. And let's have a look. So I will. There are in fact many commands in this nice application, but I just selected some of them to show you some of the capabilities. Remember that there are many other, and it's really a tool to do very complex tasks on surface models, and it's really a tool to really increase your overall productivity when you are designing complex shapes. Okay, let's start with the first one. It's a small bottle, but you know when you are making, for example, tools like that, you are really looking at having a nice aesthetic shape. And typically, this fillet is just a tangent to the walls, okay, and especially the corner. So let's replace those fillets by a blend corner. So the command is called blend corner. You can set up the so-called setbacks distance to whatever you want. Here I am using 3D Experience CATIA on a cloud. The cloud is really comfortable. All your data are secured, and you really do not take care of backup and whatever. And you see here the quality is very good. So we really replace a fillet of fillet by this so-called blend corner. This is very cool. And the quality is, of course, optimum because it's a C infinite surface. So there is of course very nice highlight on this type of capability. You see, it's very simple. Blend corner, don't forget it. So this is one of the commands of this generative shape morphing app inside 3D Experience CATIA. I will now switch to another one. Simple as well. It's called Simplify. So you receive this hood from your customer, and it's a class A surface, okay? But in fact, you would like to do some body in white, and the patch distribution is not very nice, but the surface quality is there, but the patch is not very nice. And thanks to the simplify command, you can easily replace those small teeny patches by an approximated surface. You control the quality and the deviation between the original surface and the simplified surface. But then from that, very nicely, you get a surface. It's a very nice surface. It's not class A because we approximated the class A, but it's, let's say, a class A minus, but you can reuse that very easily to do, for example, an offset, to do body in white, to do inner panels, to do any type of downstream processes. And so you can reuse this surface very easily. For example, also for a mock-up, or for 3D printing, and so on and so on. So that's one nice capability. And if we control the quality of what you did, we can measure the distance between the original surface and this simplified one. And you will see that the distance is very small because, in fact, the approximation is quite good. And of course, there will be some area where maybe it's not acceptable for you, but so you are not forced to simplify this area. You are not forced to simplify the complete model. By the way, you can just simplify locally. You see here the distance is very nice. It's almost 0, which is not 0, but 3 micron everywhere. So which is quite good for this type of model, which is not an easy one. And the patch distribution now is much nicer. Oops. Now let's start by doing some more complex stuff. It's a variable offset. So I have this freeform shape. It's not a solid. It's quite complex walls and a nice cover. And now I would like to make an offset from this original surface. And let's click on the top surface, and I will enter an offset of, let's say, 2 millimeters. I'll do the same with a different offset, let's say 4 millimeter on the vertical walls. So the 3 of them. the same offset, 4 millimeter. Here's the third one. And now for the radius, or for the blend, I will let this CATIA to just make a variable offset to go from 2 millimeters to 4 millimeters in a very, very smooth way. So here you see I select all those blends, and I will let CATIA find the right offset. I just select the value being variable. Here we go. I go on the other opposite side. You can, of course, invert the offset direction. And here's the result. Now to check the quality of the result, we can make, for example, a cross-section. So I will just intersect by a plane those two surfaces. You notice that with my action pad on the upper right corner, I can have access to my favorite command just by, in a permanent way, or just by hitting the space bar. Here I will do the intersection, and then I will just measure the distance between the two cross sections, the one of the original surface and the one of the variable offset, and check the distance. Here we are. Let's measure and let's zoom. So of course, from the wall, you have 4 millimeters of distance. From the top surface, you have 2 millimeters, and in between, you will have this variable offset. So if you are doing plastic part, if you are doing also sometimes casting part, you might have a need for this complex variable offset surface command, and you will find it in Generative Shape Morphing in 3D Experience CATIA, or Generative Shape Optimizer in CATIA V5. Now, let's have a look at another type of offset. It is so-called in CATIA, it's so-called the rough offset. Let's imagine you have this die face, a complex shape with even sharp corner, and you want to make an offset of 10 millimeters above or on the opposite direction. So here, the rough offset will offset all the surfaces, approximate the result, but it will be just one single surface, one single patch. Very nice quality. Of course, it's an approximation, so you can measure, you can control the accuracy, but you have just one surface, and you can even, you see the quality is quite good. We eliminated all the self-intersection which might occur if, for example, we had small filleting and the offset was bigger than the radius of the fillet. And let's go even further. Let's go from an offset of 80 millimeters. So this command can be used, for example, if you want to 3D print a part, let's say a bottle. The outer shape is very nice, very complex with a lot of logos, stuff like that. And you just want to make a 2 millimeters offset inside the bottle to make a hollow, to print a hollow bottle, sorry, but not a plain bottle. See, the quality is there. This is a rough offset, very nice command. And now we go to a little bit more complex stuff. Last time I showed you virtual to real shape morphing, which is the ability to compensate for spring back thanks to a scan data of a first stamp first panel of sheet metal stamped, or the results of the prediction of the distortion by FES software. In this case, we rely on the experience of the user, and the user knows that at the center of this hood, he must overcrown. We use the word in overcrown the hood to be, let's say, 1 or 2 millimeters higher than what it is actually. So we use this generative shape morphing command, which is called shape morphing. But we don't want the outside area versus this green curve to be modified. So we go into shape morphing. We select the target, which was the cross section, the initial cross section bent and moved up by a couple of millimeters. You select the limit curve, and now CATIA shape morphing will morph the original surface to match those targets, keeping a very high quality result, and of course not modifying at all outside this blue limit curve. here we go. You can we show the two results. And of course, if now we want to look at the deviation, we can again make, for example, a planar section, intersect the two surfaces by this plane, and then we'll measure the distance between the two intersecting cross section. Here we go. Let's do the intersect. It's a white curve which is displayed on the screen. Then I measure the distance between those two curves. And with the distance analysis command of CATIA, I will just measure, and you see that the max value is 3 point something. Then it is decreasing to 0, just at the limit curve that we were using to restrict locally the modification. And to finish, let's move to another capability of CATIA, which is exactly the shape morphing, the same command, but here you will see probably some things that you never saw. Maybe I am a little bit ambitious, but we will. This is a plastic part. We want to, let's say, compensate for the deformation occurring during the plastic injection molding, so the warpage, the shrinkage. And to do so, the user has the experience that he should, in fact, bend the plastic part to go from this straight line to this curved here, and to take the edge, the outer edge here of the part, and to be morphed. It is, of course, exaggerated, okay, to this arc of circle here, for example. So we will deform this yellow part according to this source, this target, this source, this target, this source, this target. Okay, should be easy, but in fact, there is an issue. So you select the target, you select the source. So here you see we have 3 types of curve, which are the source, and curve, which are the target. But you can notice that in the plastic part, I have some bosses and I have some, let's say, holes or pockets. Okay, and in fact, those bosses and holes are filleted. So we have fillets. Those parts here might be in contact with some other component inside the product. It's the same for the other side here of the pocket. And I don't want a fillet to be deformed. I want a fillet to stay as a fillet, okay? But this is not a parametric part. This is a part I receive from my customer. It's maybe a step data, so it's a dead surface. Anyway, you will see what CATIA is able to do. We will select them as rigid zones, okay? I say, create an extract, look for protrusion, bosses if you prefer. You select, automatically the selection is limited to the protrusion or the bosses, including the fillet. Now, in the similar way, I will select another rigid zone, which is not a protrusion now, but it's more a depression, to select those pockets or holes. I'm fine. You can see in blue what will not be morphed, but in fact, there will still be modified, because you see the bend is quite curvy. So what we will do is we will remove the fillet, translate and rotate those pockets and those bosses, morph the outer shell, and then remake or redesign automatically the fillet between the translated, rotated, rigid zone and the morphed outer shell. That's what CATIA does. And look at the result. If you have to do that manually, it's probably a matter of 2-3 hours, where in this case, it's just a question of minutes. Thank you, Katia, and thanks for your attention. It was a pleasure to be with you. If you have question, I have 5 minutes to answer your question. If I cannot answer your question in 5 minutes, I will for sure answer by email. And again, thank you for attending. It was the second nice jewel of CATIA called Generative Shape Morphing. Next time, I will introduce a third jewel, which is quick surface reconstruction. Any question? Oof. Okay. So again, which tool it is? It's Generative Shape Optimizer. That's the name of the app in CATIA. It's really experienced CATIA. And the similar capability is called Generative Shape Optimizer in CATIA v5. You can use this type of tool for every single complex part that you are designing. Even if you take a solid, you can extract the surfaces out of the solid, make the modifications, the morphing, the counter warpage, the counter shrinkage, for example, and then close the result to get a solid back. It's really advanced capabilities that not a lot of people are aware of, but that you can do the design with that, okay? Yeah, it's not really a piping or tubing tool, okay? It's really a tool to do a mechanical design, shape design, combine both mechanical feature and shape feature. And but it does the job, and I'm not sure you can see similar capability with such a speed and such a UI in other software. But I like my competition, no problem. So thank you very much for attending the session, and I hope you will also attend the next session. Last question. The rough offset. Of course, there is a tolerance. You saw in this presentation, I use a tolerance of 2 millimeters. I can have a smaller tolerance, of course, but it's not really recommended to have too small tolerance, because otherwise the surface, it will take much more time to compute, and it's not really to make something accurate. It's something to make an approximation, but not accurate. We don't care about accurate. If we want to do a very accurate offset, we will do a manual offset. Of course, it will fail in some other area where you have self-intersection, stuff like that, and you will have to do the job. But in some processes, you don't need an accurate offset. You just need to maintain a given thickness. For example, as I mentioned, for 3D printing, it's also for stamping. When you have the die face, you want to make the die shoe, and the die shoe thickness is probably 20, 30, 40 millimeters. So you don't care about the quality of the lower surface of the die shoe. So you have many usage of this command, and same as a simplify. So I guess we have still 2 minutes. No, I fully disagree. We have many customers who are using this tool every day. I cannot mention the name, but many customers. Let's imagine you are. I give you an example. You are doing a sneaker shoe, the sole of the sneaker shoe. Okay, the sole of the sneaker shoe is made of a lot of small details and so on and so on. And then you want to make an offset of this guy. Because it will be in foam or whatever, it's special. You don't care about all the detail. You can use a rough offset. You can say, I would like a rough offset of 0.1 millimeter, which is quite enough. And you will be able to do the rough offset of this complex, detailed surface. If you do not have any other question, I will just say hello to you. Say also thank you for attending, and I hope you will be also attending the next session about surface reconstruction. Have a nice day, have a nice evening, and talk to you soon. So, and stay tuned with CATIA. Bye bye.